In this lesson, we're going to look at some things to do with angles. I'm going to run through some angle theorems fairly quickly, just to make sure I get through them and not waste your time. But of course, you can always pause this video. You can rewind the video in case you miss anything. All right, so here we go. Angle theorems. Complementary angle theorem is one that just says that if two angles add up to 90 degrees, they're called complementary. 90 degrees, remember, is also called a right angle. So two angles that add up to a right angle are called complementary. So if I know that there's a right angle, and I know that I got a 70-degree angle, then I know the other one has to be 20 degrees because they add to 90, because they're called complementary. Supplementary angles are the exact same idea, except that they add up to 180. So again, if I know that I've got a 180, a straight line, and I know that one of the angles is, say, 110 degrees, and then I know the other angle that'll make a straight line out of it has got to be 70 degrees. That adds to 180. We've got the opposite angle theorem, OAT for short. Opposite angles of intersecting lines are equal. So if you just take two lines and cross them, then you know that the ones that are across from each other, opposite each other, are equal. So if this one's 50, then this one also has to be 50. And then I can combine that with the fact that, say, x and y, together they make a straight line, or even, don't even need to use x, let's use the one that I already know. 50 and y make a straight line. So therefore, they have to add up to 180, so y has to be 130, and z is across from y, so it also has to be 130. Angle sum of a triangle. All the angles in a triangle add up to 180 degrees. I'm sure you knew that, but that's just a quick reminder. So just triangles always add up to 180. Okay, so that's one thing we're going to look at. Then we're going to look at interior and exterior angles for polygons. So this would be if we were in class, then this would be an activity that you would do, and then we'd take it up together. But I'm just going to fast forward through it for the benefit of online. So let's just take a look at these three triangles here. The exterior angles are these lines here. So if I extend the line of a triangle, then this would be an exterior angle here, 115 degrees. Extend this one, this would be 100 degrees. Extend this one would be 142 degrees. It says here that the sum is 357, but that's just measuring error. Basically, it adds up to 360. So this idea is that exterior angles, at least for these triangles, are all going to add up to 360. So 115 plus 100 plus 142 is approximately 360. If I were to add this angle plus this angle plus this angle, it would add up to 360. This one plus this one plus this one adds up to 360. Okay, so we know that the interior of a triangle, the inside of a triangle, adds to 360. But it turns out that if we take the three exterior angles of a triangle and add them up, they also add to 360. What happens if we're dealing with a quadrilateral, a four-sided figure? Well, here's one that's a rectangle, because we got 90 degrees going on at each of these corners. I know it's 90 because of the supplementary angle theorem, right? If this is 90, this also has to be 90. But again, we got these exterior angles. If I extend to the side, then I get 90, 90, 90, 90. Well, lo and behold, that adds to 360, just like it did for triangles. If this add this one and this one and this one and this one together, you're going to get 360. And you could do this on your own. You could get a protractor and try it out if you're feeling bored, and they're going to add up to 360 in every case. Compare the triangle ones to the quadrilateral ones. There's only three angles up here in the triangles, like these three, but they add to 360 just like these three do. The way it works, the way they still add to 360, is because the triangle ones are larger angles. There's less angles, but they, of necessity, have to be bigger ones to add up to that straight line, the supplementary angles. So it still adds to 360. What happens if we got 5 sides, like in a pentagon? Well, look at that. Filled in for us, but 1, 2, 3, 4, 5 angles adding to 360. These ones will add to 360. These ones will add to 360. The angles are getting smaller, but we got more of them, still adds to 360. 6 sides, well, I think you've probably picked up on the pattern by now. Even with 6 sides, it still adds to 360. I could have 100 sides. If I follow this pattern, it's still going to add to 360. Each angle will just get very much smaller, but it still adds to 360. So the rule here is that exterior angles always add up to 360. As you can see, it's summarized for us in this table. All exterior angles add up to 360, no matter how many sides. That's worth circling. What is the sum of the exterior angle of any polygon? 360. That's just saying it in different words. All right? So that's exterior angles. Always add to 360. Interior angles are a little different. We already know that the interior of a triangle adds up to 180. And we know the interior of a square or a rectangle adds up to 360, as you can see on these first 2 rows of this table. So we got number of sides in a triangle is 3, and it adds to 180. Number of sides in a quadrilateral, square, rectangle, that adds up to 360. Now this part about number of triangles formed means, let's take a look at this down here at the bottom. Triangle, if I want to connect corners to corners, there's only one way I can make a triangle, right? So I can say I start at this corner, where I can connect to this corner, I can connect to this corner. That gives me one triangle. Big whoop. All right, what about a rectangle or a square? Again, I have to pick one corner and start from it. I can actually divide this into 2 triangles. I've got this triangle here, and I've got this triangle here. So we can divide a square into 2 triangles. That's what that's getting at. If we were to continue on with that, let's go to a pentagon, a 5-sided figure. Again, if I pick one corner to start at and see how many triangles I can divide it up into, well, I can divide it into 3 triangles, and it just keeps going up from there. So a pentagon can be divided into 3 triangles. Hexagon, I believe it is, for 6 sides can be divided into 4. Septagon into 5. Octagon into 6. And this goes all the way up to a 14-sided figure down here at the bottom. Although we could extend it to more. We could go to 100-sided or 1,000,000-sided. The pattern's going to hold. And what is the pattern anyway? I was talking about how many sides this has. A 14-sided figure has 12 triangles. That means that a 13-sided figure has 11 triangles. And a 12-sided figure has 10 triangles. And then let's get back down to the ones we actually know. Like a pentagon, we know that's 5-sided, 3 triangles. Square, we know that's 4-sided, 2 triangles. So, if you take the number of sides on a shape, subtract 2, that's how many triangles you'll be able to fit inside it. So a 4-sided figure, take away 2, gives me 2 triangles. A 5-sided figure, take away 2, gives me 3 triangles. That's what this table is getting at. So when it talks about number of triangles formed, you can form 1 out of a triangle, you can form 2 out of a quadrilateral, you can form 3 out of a pentagon, right? Pentagon's got 5 sides, and you can form 3 triangles out of it. So what? Well, a triangle we know has got an interior sum of 180 degrees. And so if we do 1 times 180, we get 180. If we do 2 times 180, we get 360. If we do 3 times 180, we get 540. And that's actually how many degrees are inside each of these shapes. So a triangle has 180 degrees total sum inside it. We already saw that. The angle sum theorem at the beginning of this lesson. You've known for a long time that a quadrilateral, a rectangle, a square, has 360 degrees in it. But here's one way of explaining it. It's made up of two triangles. You may or may not have known that a pentagon's 540 degrees, and we can explain it because it's got three triangles in it. And it just keeps going up from that. A hexagon, a six-sided figure, is made up of four triangles, so it's got 720 degrees in it. An octagon, I'm just going to jump ahead a bit, I don't want to hit every one of them. An octagon's got 8 sides, so therefore 6 triangles. I know that the interior angles of an octagon will always be 1080. So that's helpful. We can actually make it into a formula. So that's what's happening in this last row here. In the last row, they're saying, what about an n-sided figure? Or what's n? N is anything you want. If n was 20, then we'd be able to have 18 triangles inside a 20-sided figure. If n was 100, then we would have 98 triangles inside a 100-sided figure. So what we do is we multiply the number of sides of the triangle, or not triangle, the number of sides of the shape. We take away 2 from that, n minus 2 times 180. And that will always give us the interior angles of a shape. This part here, you don't have to memorize this. This is just if you simplify what I highlighted in yellow right beside it, n minus 2 times 180 simplifies to 180 n minus 360. But don't worry about that. Stick with the one that is here in orange, and that will be the easiest one to use. So again, let's just do a mental thought experiment. What if I asked you how many degrees are inside a 50-sided figure? Well, you're going to do 50 minus 2 is 48, and you're going to multiply that by 180, whatever that comes to.